Hello, hello, hello.
Oh, wait, we can.
Oh, I see. It's okay. I'm gonna just try without it. All right. So yeah, I need to open my slide actually. All right. So today I want to talk about offline AI. So running LLM on your local machine without Claude, without OpenAI, without server. So yeah, I am Jhin. I'm Google developer expert, called in short GDE, and I like Flutter and Dart, and I'm specialized in that. And yeah, I'm in part of the organizer. So I put the FlutterMtl Meetup at there. I don't even put my company name there.
So many titles.
Yeah, so I want to make it short. All right. So yeah, I mean, I don't know if any one of you came to my one of talk at another meetup about QAI. I did a demo at the AI Tinker or another meetup that I built an AI app. This is my personal AI writing assistant app that actually I'm using daily basis. I made this app a few months ago, and yeah, I'm always using. Actually, I can do short demo because that is linked to my motivation why I made this the package. So let's say I go to the LinkedIn and let's say I want to post something. For your information, I'm not native English speaker. I don't speak French well, but I live in here, so I don't want to make mistake, those kind of thing, right? So let's say, hi, oh, Korean. Hi, I'm Jin. I'm here at the Florida meetup. I will talk about llamadart, and yeah, I can also make some kind of grammar mistake. Let's say, hi, I hear the Florida meetup. Me, Jin, whatever. And when I, whatever the language. So I made a lot of mistake here, right? On purpose or whatever. And then I trigger some button that open up this pop-up and I can correct it. So here, okay, I am gonna change the model. Just a second. So I'm here, I'm using, I don't know if it's too small. Can I zoom in? I will try. Yeah, that's good. So here I'm using Gemini 3 Flash model. And when I click number one, then it corrects. Okay, hi, I'm Jin. I'm here at the Florida meetup, and I will be talking about llamadart. Sounds like correct now, right? But what if I want to post it into LinkedIn? So I'm gonna change my style of writing for LinkedIn. Now let me make it big. There again. Is it good? And and then when I enter, then it will replace the post. So that's nowadays how I write LinkedIn posting or social posting. So easy, right? So I'm gonna make it or trigger again, and I'm gonna make it like Quebecois. So let me know if that sounds like Quebecois. Do you see anything? Yeah. Is it French or Quebecer? Yeah. So yeah, and then I can replace it. Then I can post Quebecois, like pretending like Quebecois, posting messages in LinkedIn. So that's basically app I built, right? But the thing is that I was imagining that preparing presentation or writing something in a plane. There's no guarantee of having the internet, right? Since this one is connected to Gemini, I cannot use this app in that way. So I need it. I'm gonna select again. Here, I integrated Translate Gemma for the model and 12, but offline model. So this app is capable to run offline AI, basically. So I don't know, it's gonna work fine. Hopefully there's no demo effect. Yeah, it did, kind of. So apparently there are some issues with that previous things. But yeah, I mean, this one is completely offline. There's no internet connected, no Gemini, nothing. It's just using the offline model, translate Gemma on my local machine. So my Mac is powerful enough. Sorry? Exactly. You notice that now, all right? So yeah, I mean, so this app, my intention of making this plugin, llamadart, is for that. I want you to use it myself, offline AI in my application, right? Oof. So let's get back to the, I'm gonna close it just so that I don't make mistake. All right. So go back to the presentation. Yeah. So with Gemini, online model is perfectly fine. It's good. But what if you don't have internet? And what if you need to deal with private, some sensitive information you cannot ship to the cloud, right? Or over the network. That is the why I have the, made this package so that anyone can make your application offline AI. Okay. So what I use is a Llama CPP. Anyone know about Llama CPP? You know, okay, few people. So Llama CPP must be, most famous offline AI engine. You can actually use it. That is memory efficient. So in my Mac, I can easily run quite huge model on my even Mac OS. I mean, small or big, but I mean, that is really optimized, and there's no the boundary of the hardware. If you have GPU, you accelerate with the GPU, CPU optimization or whatever. Llama CPP doesn't care. I mean, Llama CPP supports many different hardware with acceleration. And GGUF, if you go to the Hugging Face, if you search about the model, most of famous model support GGUF format. So let's say you use the TensorFlow, I mean TF Lite now, and then the MediaPipe or different options out there, but they require some specific model, and quite often it doesn't support the latest model. So that's why I picked the Llama CPP. But the problem is that, the problem is that was on our slide. So before that, Llama CPP is, I mean, those are the famous products using Llama CPP behind. So probably many of you already know Llama and Llama LM Studio. They are actually using Llama CPP behind. So many of people using Llama and the LM Studio to run local model and connect to the cloud so that they don't want to pay to Anthropic models, right? So yeah, those are using the Llama CPP, meaning that it's kind of proven for the performance and a lot of people using it. And I put Gen AI, but this honestly, I don't know too much. I asked the Gemini which famous the product is using Llama CPP, and then Gen AI was one of them. And actually, I check it out. It actually kind of ChatGPT with the AI is quite good, actually, I noticed. And yeah, so the problem is that Llama CPP, great, I understand that. But the thing is that if you want to use it, you need to compile. It's C and C++, the giant project. So you need to compile for each model. Flutter support cross-platform, Windows, Mac, the Linux, iOS, Android, even web, right? But if you have C++ code somewhere in your code bases, you need to make a compile in each platform. That is kind of nightmare, right? So I made it pre-compile all the library per platform, put into the GitHub, the GitHub space. Then when you are using, if you use llamadart, then you don't need to deal with the compilation. It's already there. You don't need to think about it. That's basically what I did with llamadart. So yeah, I mean, the really high level. So let's say you have the Flutter app running, mostly UI, or it can be Dart app, whatever it is. And you just call the llamadart API. And then llamadart is taking care of all the native parts, all the the FFI or something isolation. For example, if you don't use isolation, it will block the UI, that it makes some kind of jankiness on your the Flutter app. But yeah, you don't need to worry about that. I taking care of all the nightmare stuff. So you just need to use it. Then you're ready to make the offline AA ready application. And yeah, I put the isolation, FFI, and yeah, dev experience is basically about API. That, because I'm providing high-level API, so you don't need to worry about, too much the complication, how to use Llama CPP, and so on. And yeah, to do that, what I did, I briefly explained to you already. I'm gonna show you later how I actually do this. But in Dart, they introduced native asset feature. I think it's introduced in the Dart 3.6. I don't just remember the version, but that is making it happen. So what I did, I have the dedicated repository in GitHub. It always compile latest version of the Llama CPP. And then when you, in llamadart, if you are a user of the llamadart in your application project, that it downloads it when you are compiling your app instead of downloading source code and compile. That way, you don't need to worry about, C++ compile the environment for each platform. That's what I did. And it automatically detects your platform. So, it downloads exact library instead of downloading, instead of downloading the all compiled libraries.
From where does it download it?
In your local project.
From your local project that you've built yourself?
Yes. Yeah, developers. So let's say you are the developer. Let's say you are the llamadart user. So you are using llamadart in your project. That when you compile your application, that is the moment that download from the GitHub.
It downloads the source code or a binary?
Binary.
A binary.
Yeah.
Okay,
Yeah.
so
That's why you don't need to worry about the compilation environment.
So you don't have to compile Llama CPP
Exactly.
yourself.
Exactly.
Pre-compiled binary.
Exactly. Yeah. It's the same thing for the web. So when I want to make a support web in Flutter, then I had to compile Llama CPP in Wasm. And the same thing, I use the GitHub as a CDN. So when you're making the web compile for the Flutter app, it just use it on the web. So you don't even need to worry about the, which library you need to download, how you compile, or so on. So single code basis, you can support web and all the cross-platform basically. And yeah, there's two benefits. Benefit for maintainers, myself, and some, open source contributors and developers. As a maintainer, I don't need to deal with the C++ again. So that's still a good benefit for me because I already set it up all the environment. So if I don't have that, the native asset, then I should have done the same thing. Probably, I download or embed the Llama CPP code in my project, llamadart project code bases, and then I need to make sure they're providing all the information, how to set up the compile information. And then, I don't know if you know how crazy to set up build the environment for iOS, Android, and all different. That's actually crazy. But native asset make it so easy for myself. And also for developer, same thing. You don't need to deal with all the nightmare, how to compile, image file, or build Gradle path file. That is going to be automatically all taken by the llamadart, basically. So yes. So native asset is just feature name. So native asset meaning that the Dart has a way to automatically, how can I say, the compile or download the pre-compiled library or those kind of things. So deal with the native, the compiled libraries much easier. So they call it hook as well. That's why, when you compile, let's say you compile for the Flutter web, web is not a good example. Let's say Android, then the hook is going to decide which one to download it. Same for the iOS. And then also it also wire up with all the path file and also on. So you don't need to deal with all those kind of things. I don't know if you try to use the Firestore iOS, it takes forever to compile because it's written in native. But I don't have that here because we just downloaded everything pre-compiled.
What if the repository that you're working in doesn't have pre-compiled versions? And then you have to suffer the...
That's my duty as a maintainer of the llamadart. So
Okay.
yeah, so I always make sure that all the platform native binary is available.
It's always a bit.
Yeah.
Okay.
That's why I'm using GitHub. Basically, I don't want to manage my storage or something. I mean, GitHub, I upload as a release there, then you can just download it, basically. Right?
Okay. That's reassuring.
Yeah. And what I said about the who and the so on, in Llama CPP, like I say, it supports different GPU using CUDA or the AMD GPUs and OpenCL, Vulkan. And if you know the ARM has so many different versions. They all have different hardware acceleration features, right? So there's so many different libraries I need to compile. So what I did is that I could just use the best one. But if I do this, probably your package size is going to be big for your application. Or maybe it can be crashed in the low tier devices because let's say this CPU has something hardware the acceleration library, but if you use the devices doesn't support that feature, then it's going to crash. So I made it sure that you can customize it. What kind of native binary you want to embed in your package. So that's why I made a system that you can customizable in PubSpec. I'm going to show you that later as well. And GPU acceleration is not always best option. So let's say on mobile devices, based on my testing, it's not always good. I mean, sometimes the CPU, most of the time, CPU running much better than GPU on mobile. So I mean, I made it kind of optional. iOS is a kind of exception. So iOS, they have kind of special architecture with the metal and then the universal memory, so on. So I noticed that on iOS and Mac, GPU acceleration is really working great, even without special the configuration all the time. And yeah, I already talked about web. So I made a bridge. So same thing, I have another repository dedicated, always compile Llama CPP into WASM, and it used web GPU. So you can still have the GPU acceleration in your browser. And that project called the Llama Web Bridge, that one is not only for the llamadart, actually. So you can, if you have, because that project is using JavaScript in it to integrate the Flutter. So if you want to have, let's say, React Native or React application that use llamadart load on the web, then you can free to use it, by the way. So, but I mean, I made that bridge on purpose to be, the general use, but I use it in llamadart so that I can fully support all cross-platform that Flutter supports. And yeah, I mean, API, same thing. So I have all the bridge code for the web as well on the llamadart site. So, I mean, just same code. It's gonna run, if you compile web, it's gonna run on the web. If you compile for the iOS, it will run on iOS. Everything is gonna be one code basis. And yeah, it's time for the demo, basically. So I want to demo macOS demo and web, mobile, and some other use cases like thanks to Dart, you can even make a server. So open API related, the compatible server, something like Llama basically. So I can show you, I'm gonna show you how I built it, and then some CLI coding agent. So I built it as well. So let's go to the demo. Which one first? All right, so I have the macOS. Let me make it big. Probably still small. I'm gonna zoom in. So here you can load different models. I already preloaded Gemma 4, which is pretty latest, the high performing models. And you can configure different the model parameter. So the backend here, the GPU, the Meta, because I'm using the Mac, and you can configure how many GPU layer, meaning that there's different layers, how many GPU you want to use it. So meaning that you can actually hybrid. So until this, it's using GPU. After that, CPU. That way you can customize the performance as well. And how many threads, how many batch threads, and you can also configure different the model configuration, the inference config. So temperature, top K, top P. Yes. It depending on the device. So if you have the powerful device with the GPU, with the CUDA, I mean NVIDIA, powerful GPU, then you can go crazy. But on Mac, I think you could, I mean, that also depending on how much memory you have. But let's say, let's say if you have 128 gig memory, probably you can go up to 120 billion token model, but it's going to be super tight. It's going to use all your memory, right? So you need to kind of, balance out. Let's say if you want to use it for your coding agent, then I think you need at least 8 billion token model. But yeah, then you are not going to have much memory left.
You have those resources?
How many again?
You can go serverless.
But it's full. Develop a coding.
Yeah.
Maybe quickly, I don't know the specs of your machine, but if you use, let's say, Gem 4 with your current setup, what kind of tokens per second are you getting to?
So I actually have the token per second, in the UI there. Let me actually, show you. Hi. Maybe I better. Even it's gonna be too small, but I hope you can see it. If I just say hi, then yeah, token per second here, I see 4. No, actually no. Token per second there.
Can you know?
Let
Maybe
me.
you should ask it something more complex that we will see running.
Yeah. So yeah.
I think what he's asking is it burn more tokens than float code?
Sorry?
Does it burn more tokens than float code?
No, that's depending on the model. So it's not. Yeah, cloud code. You're gonna count about how much token you burn. Yeah, he's talking about the speed. Yeah, but here actually I don't have really accurate speed here. But I mean, I think the decoding token per second, this might be more accurate than the actually average token here, because you saw that the 1.3 token per second doesn't make sense. It was way more faster. So let's say write a poem about Flutter. Yeah, it's faster, right? Yeah. But I mean, it's saying that average token 18.5, but I think it was way faster than that, right? So I think the chip is not really actually accurate.
So your decode is saying what, 200?
Yeah, decode is actually 19.1. It actually went down. But I mean, yeah, I mean, I don't think that is actually accurate here. But yeah, I mean, it really depending on the model, and this model is fairly small one. It's only 2 billion E, so it's equivalent to 4 billion model actually. But this one is small enough you can even run on mobile devices. I tried it on my Pixel. It's not super fast, but good enough to use it.
What is the largest Gem 4 model that you run on your laptop?
I think Gemma 4 largest model, I don't remember what size was it, 32 billion or even bigger. But that one is easy. I can run it easily on my Mac, but not on mobile. Yeah. So I mean, it's usable. I mean, Gemma 4 2B model still it's not bad, but still it's working. And then if you go 4 billion model for the Gemma 4, it's actually not bad. I mean, you can use quite general purpose. You cannot do the coding, but yeah, that's actually quite not bad model. Yeah, this is the app for the macOS. So if I make it smaller, you see, it become like mobile format, right? So it comes to there, and then I can have multiple conversation like that, right? And because it's single code basis, the same UI, I have it on mobile, iOS. It's too small, I know, but same thing. I can do the same thing. Write poem about Flutter. But honestly, this is not fair comparison because this is simulator. It's way faster than actual iOS. The phone, right? It's using the Mac power, right? So, but still, I mean, I just wanted to show you that also. Android, this one is emulator, right? So this, I didn't use the Llama 4, but I can show you the QN 3.5, another famous model. So let's say hi. Yeah, still not bad, right? Do the same thing, right? Poem about Flutter. Yeah. So you see it's slower, but actually on mobile devices, it's actually going to be faster depending on your device because this one is emulation, right? But yeah, I mean, QN 3.5, this one is 0.8 billion model, really small one, but still, you can use it, small jobs, small purpose, this kind of thing. And next is going to be web. So this is my document site. I created, I generated, and I have the link to try out the chat app. When you click this, it goes to web. But loading the model takes some time, so I preloaded already. So this I'm gonna, which one? This one loaded. Okay, I'm gonna close this one. So I'm gonna show you how it works. Same thing with the web. So if I make it smaller, then it goes to mobile view. Just prove that this is same Flutter app, right? And yeah, here, write a poem about Flutter, same thing. Then yeah, it's running. It's using web GPU, if you see here. It's using web GPU. But I think I don't see much difference between using web GPU and CPU, on my machine at least. But probably depending on your machine, actually. And I think the web GPU is obviously slower than the natively using Meta GPU, but still, I mean, it works. You have all the feature. You can customize it with web GPU and CPU. You can play with the GPU layers so that you can load balance it GPU and CPU. And yeah, that is the example for the web. And let's go with some console example. So this example is the coding agent I built, generated. Oh, start, run, and who knows this interface? Anyone knows? Anyone familiar with this interface? You? Yeah? Exactly. Yeah, I want you to mimic Turbo C, but with an agent. So here, let's say, what is this project for? So here I'm using GLM 4.7 Flash model. And this one is fairly big. And this can do little coding stuff, but not as good as Claude for sure. But this one is fairly big model that I can use. I mean, you see, I even have the mouse moving window. And yeah, it's explaining about this project. So this is coding agent TUI. So I created this TUI. This is the Dart CLI app basically, right? So, and coding agent session and so on. I can even do I can create new window, new session. And you have I can even use a mouse to do all this. And when you try to quit, then it has a pop-up that I can do this. I really try to mimic the Turbo C. But yeah, I mean, you can build, it's not only about the Flutter. So you can do pure Dart app with offline AI. that's what I wanted to show you first. And then, yeah, another example, it's a server. Let's say you want to build a server running offline AI on the server side. So you want to serve it as the open API, API service. Then this application has Swagger implemented, integrated. So I can show you easily demo here. So this is the backend server that I'm running on my local machine. So this, you see there's a 127, I'm connecting to it with a browser to the Swagger interface. And if you run it, so here you see the system prompt, you are concise. And then the user, this is the actual prompt that I'm giving. Give one sentence about Seoul. Then it's giving me that the assistant is replying, Seoul is vibrant metropolis where culture, whatever, yeah? So this is the exact way the Ollama is doing. So you use the open API compatible server and then connect with the cloud code. And that way you can run your local, LLM cloud code on your machine. And yeah, or you can serve like to your services and so on. So you can use this way, Dart backend serving the AI that you can do. And what did I miss? Let me see. CLI, I talked about it. Yeah, one thing I wanted to show you more is this. I'm going to talk about later a little bit. So it also supports the fine tuning, the LoRa. So you can, I created notebook that you can just follow. It's Python, it's notebook, right? So you can train your own model, and then you can put on top of the model that make it the model more response to your own needs. Let's say you want to use the Gemma 4, but it's more medical oriented, then you can train for the medical, that even the local model will be really the niche to certain area that you can do it too. And yeah, it also supports embedding. So if you want to create a rack, then with this, you can take the embeddings and then save into the rack and so on. You can also do that too. So let's see. Yeah, how to use it? Simple. Just add dependency, and then the code is simple, right? You just initialize the engine, load the model you want to have, and yeah, you call generate, then that's it. That's what you're gonna do. That's all. And how to find model? Like I say, the GGUF model, the format. If I can show you, if you go to Hugging Face, and here, where you're gonna go? Let me teach you more. You go to the model, and then on the left, you see the library GGUF. Then you will see all the available models. You see Gemma 4, Minimax, all the famous models are already there. So you have wide model choices you want to use it. You can pick whatever the model you want to use it with the Llama CPP, and that's it. That's what you can do. And yeah, and then I already talked about the LoRa, the fine tuning. So you can train your own model, and you can use embedding if you want to do the rack. And I recently created another library, Jenkit llamadart. So Google released Jenkit Dart, meaning that now Jenkit can, you can use Dart to build the Jenkit application, which is the kind of, how can I say, the pydantic or, some kind of, or LangGraph, or those kind of framework made by Jenkit. So you can have, you don't need to worry about the agentic behavior. So with the Jenkit llamadart, you can still use offline model with Jenkit, meaning that you can have the agentic behavior that you already saw the CLI example, the TOI example, coding agent I built. I built all the agentic loop myself, but you don't need to worry about that anymore. You just use Jenkit, then it will make it, super easy. And yeah, these are just some links that if you're interested, probably we're gonna share the slide. And yeah, so some documentation and my library, the packages in PubDev and GitHub repo if you are interested looking at it. And before question, sorry, before question, I didn't show you the code, right? Probably you want to know, you want to see this. I think I still have 5 minutes, right?
You share your
Yeah. So for the code-wise, I mean, it's pretty, oh, okay. I don't want to mess up. Okay. Yeah, code-wise, pretty simple. I don't have any, native related code here. No iOS folder, no Android folder, thanks to the native asset. So I have that, all the logic here, build.dart. This guy is automatically determine which native binary to download for your application. And then, exactly. And I need to show you this, not this. Here, the documentation. Same thing, I'm gonna zoom in more. So here, platform and backend metrics. So I listed up all the supported platform and then backend choices, GPU or CPU. So yeah, you see how many combination I support. And this is the compatibility list. And then this is what I talked about. You can customize it. Which platform, which system you actually want to support in your application. So let's say for CUDA, that is like 200 megabytes. Probably you don't want to embed in the Android package, right? Probably desktop is fine for Windows, but you don't want to do that. So that's why I made it, configurable so that you can have your own choice. And yeah, this is what I talked about. Depending on the ARM, they have different feature support. It's all about the hardware acceleration. So let's say this is working on the latest devices and then the older devices. But if you use this one only in the older devices, then it's gonna crash because there's no instruction available in the device, in the hardware. So you can choose how many devices you want to support. If you are going to certain, let's say last year model, then maybe you want to go this. If you want to support 4 years, maybe you need to go there, or you really need to support like 10 years ago model, then you're gonna go all this so that you can decide your coverage of support of your application this way. And yeah, that was about it. Time for the question now. Thank you. No question?
I saw that you were using anti-gravity.
Yes.
Your IDE. Maybe in your workflow, are you somehow also kind of relying on your local models that you somehow wired to your IDE, or you don't do that at all?
I have the ChatGPT plan. So actually, I don't leverage my local models for that, but it's more for the application. So like I already showed you QAI. So I needed offline model, so I used Llama. I mean, initially I used Llama CPP directly, and I made it work on macOS, and I want to support Windows as well. And then it became kind of nightmare. I need to set up all the CPP build environment on the Windows, and I don't use Windows a lot. So it was really hard to make it work. So that was the moment that, okay, now I'm gonna make it package, so everyone can just use it. So that's what I did. Yes.
The two example that you had, is there a Dart 2 library that you use?
Yes, that's called Noctum library. I think probably it's said about this. No, it's not saying that. But yeah, I mean, there's the package called Noctum that makes easily making TUI interface. Yeah. NOCTERM. Yeah. I think this took like a few hours actually only to make this all UI. Yeah, it's kind of, nostalgic for me. When I start, programming, that was the interface. Oh, Pascal, yeah, Turbo Pascal is in here thinking. Yeah. If there's no more question, then we can close it. Thank you very much.